Hello, and probably good afternoon for you guys. It's actually afternoon right now. Today is Tuesday. I just finished my Google Meet with about 10 of you guys. Had a few questions from you about things that are coming up. So it was really nice to chat and connect with all of you guys. Really nice, actually. So thanks for joining the Google Meet, and we'll have at least one more before we're done the course, since we're wrapping things up fairly quickly. If you've taken a look at the weekly memo, you'll realize that. So I attached the notes for you to print off to this lesson today. How many pages have I got here? I just printed them off myself. I've been trying to condense these things so that you're not going through too much paper. 1, 2, 3, 4, 5, 6, 7, 8 pages. Okay, so 8 pages. Hopefully you've got a printer and access to be able to do that. It's nice to be able to fill in notes as you go along on these lessons to kind of keep you organized and paying attention. It's kind of boring if you're just sitting and listening with nothing to do. So today we're going to spend 2 days on chapter 7. Today is new material. Tomorrow is a review of all of the stoichiometry methods that we used throughout other sections of the course. So we've kind of been doing chapter 7 as we've been going along. So that's why we can do it in 2 days. And then we start chapter 8, and there's 4 or 5 lessons in chapter 8, and then we're done the course. So it's coming fast and furious. Wow. Okay, let's dig into this. So today you're going to be writing chemical reaction equations. And before we do that, you have to know the 4 assumptions that we make in Chemistry 20. So we assume that every time we're looking at a reaction, it's spontaneous. That means that it happens pretty much on its own. When we mix reactant A with reactant B, they will spontaneously react. It happens fast and it happens complete. And complete means 100%. And finally, it's balanced. So if we had 2 moles of A reacting with 1 mole of B to make 1A2B, we would have that balanced equation. So this is spontaneous. Mix them together, it happens. It's quick, it's complete, 100% product and balanced. So that's sort of the rule for all reactions in Chem 20. Today we're going to be looking at single and double replacement reactions. And what you have to realize, we haven't done this before, but there are some single and double replacement reactions where not every chemical is actually part of the reaction. And if you are not part of the reaction, you have a special name. You're called a spectator ion. Just like spectators at the game cheer from the sideline, but they're not involved in the actual on-the-field play. Same thing in chemistry. If you're an ion and you're not taking part in the reaction, you're just watching from the sidelines, you're called a spectator ion. And we're going to remove those from the reaction. They're not included in what we call the net ionic equation. So today you're going to learn how to write net ionic equations where we remove spectator ions. Okay, and that's our goal. Today's lesson is not too bad. These are the rules, and you have these in your notes. This is from your textbook. You always have to start with a complete balanced chemical equation. So that part we know. Then we're going to dissociate all the high solubility ionic compounds. And so this is where you had to learn chapter 5. Dissociate high solubility ionics. Ionize any strong acids to show complete ionic equations. And then this is the new part. You're going to cancel out identical entities that appear on both the reactant and the product sides. Once those spectator ions are canceled out, I'll just put spectators. They're not always ions, but usually. Once they're canceled out, then we can write our net ionic equation and simplify. Okay, so practice makes perfect. We'll go through like 3 or 4 or 5 examples, so you'll get this dialed in. Okay, so start with the balanced equation. Zinc metal. Zinc solid reacts with copper 2, so Cu2 plus. SO4 is a 2 minus, so 1 to 1, and it's a solution, aqueous. Okay, so we have a metal and an ionic. So that'll be a single replacement. The metals will trade. So the copper gets kicked out as copper solid. The zinc replaces it as zinc sulfate. And zinc is a 2 plus. So sulfate is a 2 minus. Okay. So that's a Chem 20 reaction, but now we want the net ionic reaction. So we have to see if there's any spectator ions. So dissociate all high solubility ionics. So copper sulfate is high solubility aqueous, so it's going to get broken apart. So I'm just going to put down here, the zinc doesn't change, it's an element. The copper sulfate, this is what it looks like in solution. Those would be the major entities present, MEP. Remember that from chapter 5, dissociate high solubilities. Okay, on the product side, the element doesn't change. This one's also high solubility. If I was looking on my periodic table in the solubility chart, I would see that sulfate right here and zinc is in the most. So that's why that one dissociates, and copper sulfate is also in the high solubility chart. It's none, these are all the low solubilities, and there aren't zinc and copper not in there. They're very soluble, which means they are completely dissociated into their ions. Okay, so there we go. Dissociate the ionics. There's no acids in here to ionize. Okay, so that's our second step. Now, cancel out entities that appear on both reactant and product sides. So take a look at our reactants, and then take a look at the products. Is there anything that does not change on either side? Okay, the sulfates. So those cancel out. Those are spectator ions. So SO4 2 minus is gone. Now we go to step number 4 and we rewrite the net ionic equation with whatever's left. So here is the actual solid reaction. Zinc solid reacts with copper 2 plus to make copper solid and zinc 2 plus. Sulfate has nothing to do with this reaction. It's a spectator ion. So this is our net ionic equation. Interesting. And if you're looking at it going, that's weird, kind of, what's actually happening here is 2 electrons are being transferred. And they're being transferred from the zinc to the copper. You don't need to know this, but you will in Chem 30. So if zinc loses 2 electrons, it becomes zinc 2 plus. If copper 2 plus gains 2 negative electrons, it becomes copper solid. So this reaction is a transfer of 2 electrons, and the sulfate has nothing to do with it. Okay, determine the net ionic equation for copper metal with silver nitrate. So we need a balanced chemical equation. Copper metal, silver's an Ag plus, nitrate's an NO3 minus, and its solution. So this is another single replacement. Now when we go to write copper nitrate, copper is multivalent. There's a 1 plus and a 2 plus. So we have to figure out which one is it. Okay, copper 2 plus is the top one, so that's more common. So we're going to be using the copper 2. Nitrate is a 1 minus, so we'll need 2 of them. And it is solubility, copper nitrate. For solubility is, nitrates tend to be high solubility with everything. There's nitrate, and it's none of those. It's in the most high solubility aqueous. And silver solid left over. Okay, now dissociate all the aqueous ionics. So the copper solid doesn't change. This dissociates. This one's also aqueous, high solubility, so it dissociates. Oh dear, I messed up. Stop. I forgot to balance my equation. So I'm going to go back and balance it. 1 silver, 1 silver, 1 copper, 2 nitrates. So I need to put a 2 in front of that. 2 nitrates, 2 silver, 2 silver. Okay, now it's balanced. So I have to go back and put a 2 there. I have to put a 2 there. I'm just going to clean that up a little bit. Move that plus sign. Okay, copper 2 plus, 2 nitrate ions, high solubility, and 2 silver solid. Okay, so now we get our pen ready to cancel out spectator ions. Are there any? Comparing both sides, we have 2 nitrates, 2 nitrates. Everything else is different. Okay, so this is similar to that last reaction. It looks like it's one of the ones where we're transferring electrons. Copper reacts with 2 silver plus aqueous to produce copper 2 plus and 2 silver solid. There's our net ionic equation. So it looks like copper was giving 2 electrons to the 2, so 1 electron to each of the silvers to go from 1 plus to neutral, no charge. So transfer of 2 electrons, interesting. Here's what the reaction looks like. Here's our Cu solid, and you will notice that the water is turning blue, which means Cu2 plus, and the copper is getting coated with a shiny silver colored Ag solid. So in the end, we get copper 2 plus and Ag solid forming on the copper metal, and that makes sense looking at our net ionic equation. The solid copper turns into blue, copper 2 plus, and the Ag plus, which is colorless, so the Ag plus was in here, turns into Ag solid, silver. Nice. Okay. 2 down. Write the net ionic equation for the reaction between solutions of lead 2 nitrate. Lead 2 plus, NO3 is a 1 minus, so we'll need 2 of those, and it's a solution. Na plus, I minus, 1 to 1. So this one's going to be a double replacement because we have 2 ionic compounds. So lead 2 plus, iodide is a 1 minus, so we'll need 2 of those. And PbI2, NaNO3. Na is a 1 plus, NO3 is a 1 minus. And balancing it, 2 nitrates, 2 nitrates, 2 of those, 2 of those. And states. Let's go look up states. NaNO3 and PbI2. So nitrates, high solubility with everything. So Na plus is in there. PbI2, so here's iodide, and here's Pb, low solubility. So that means that one's a solid. Solid, aqueous. Okay, so dissociate all our high solubility ionics. I got to spread this out a bit. Pb2 plus, 2 NO3 minus, 2 Na plus, 2 I minus. This is a solid, so it stays together. It's low solubility. 2 Na plus and 2 NO3 minus. Okay, dissociated that one as a high solubility. Let's change colors. So spectator ions, who are we crossing out? Take a look. 2 nitrates are gone on both sides, 2 nitrate aqueous and the 2 Na plus aqueous. Okay, so this is shortened quite a bit. So here's the real reaction. Pb2 plus reacts with 2I minus to produce PbI2 solid. So Na plus, NO3 minus are spectator ions. They have nothing to do with the reaction. Wow. I see Dr. Hinshaw, you just got a little pop up there. Graduation, congratulations. Nice. Okay. There's our net ionic equation. Nice. Okay, moving on. Oh, I decided to Germanize this one. What is the net ionic equation when solutions of barium chloride and sodium sulfate are mixed? And sure, we'll do this one. Barium chloride. So what I'm going to do is just get you started. Barium 2 plus, chloride is 1 minus, and it's a solution, aqueous. Sodium sulfate 1 plus, SO4 is a 2 minus. We'll need 2 of those, and it's a solution. So this looks like a double replacement. I am going to suggest that you stop here, try this one on your own. So pause the video and then come back and see how you did. Do all 3 steps, see if you get this one right. Okay, so now I will continue on. BaSO4, and I believe that one is sulfate barium right there. So high solubility solid, low solubility solid, and barium sulfate sodium chloride, and we'll need 2 of those to balance it. It's definitely high solubility. Okay, that one's balanced. We've got all the states. So dissociate the aqueous ionics. I don't know why, but it's so much faster now when I write and talk. It stays up to date. Remember some of those earlier lessons where it was so chunky and way behind and it made everything so messy because it was trying to catch up. Okay, that one's a solid. It stays together. And the last one I break apart. So 3 of the 4 are high solubility, so they break apart. There we go. Okay, spectator ions, cancel them out. Who are they? 2 Na plus are gone, and 2 Cl minus are gone. So the real reaction is barium 2 plus reacts completely with SO4 2 minus ions floating around aqueous to make a solid precipitate. So we would call that a precipitate. Barium sulfate. By the way, that's the white milky solid that they make you drink if you have to get an x-ray of your gastrointestinal tract. X-rays only bounce off of bones. They don't bounce off of soft tissue. So if you need your stomach or your large or small intestine x-rayed, you drink this solid, pasty white milkshake, and then the x-rays will bounce off of this pasty solid as it's traveling through your digestive tract, and you can see the shape of the structures to get a visual image. If you have some issues going on with your stomach, large or small intestine, it's a way for them to see it without cutting you open. Barium milkshake, they call it. Nice. Okay, I think we have one left and we're done. Woohoo. We're just rolling along. Okay, write a net ionic equation for a solution of hydrochloric acid and barium hydroxide. Okay, hydrochloric acid reacts with barium hydroxide. We will be doing a double replacement, so that will be HOH or H2O. Water is a liquid. And BaCl2, I think that's high solubility. Chloride there, and barium is not in this list, it's here. High solubility, aqueous. Okay, this one's a little tricky. This is an acid, so we break it apart or ionize it. It's like an ionic compound, strong acids. Remember, there's 6 strong acids, and we can break all 6 of them apart into their 2 ions. Plus Ba2 plus. Whoops, that's a solution, aqueous. Plus 2OH minus, aqueous. And I messed up, I didn't balance it. I need to put a 2 in front of there. And then it's balanced. Oh no, I lied, a 2 in front of there. Oh boy. Mr. Johnson, you can do better. Okay. 2H plus, 2Cl minus, 1 barium 2 plus, 2 hydroxides, and we get 2HOH liquid and BaCl. Whoops, jumping the gun. That's aqueous, so that's Ba2 plus and 2Cl minus. Aqueous, aqueous. Okay, spectator ions. Barium 2 plus is gone. 2Cl minus is gone. Wow, isn't that interesting? This is a classic acid-base neutralization. The two acidic protons react with the two basic hydroxides to give water. There is your net. It's not really in, well, it's kind of ionic. Yeah, it is. It's got two ions in it. Net ionic equation. The acid reacts with the base to give neutral water. Cool. Aqueous, aqueous, and liquid. Okay, that, ladies and gentlemen, is it. So there is one page that you can do, net ionic equations, really good practice. It's in your study guide. And I am unorganized. I'm flipping right now to see which page it's on. This is not good because it's probably in a weird spot that I can't find. Stuck to another page. Next, stoic, net ionic. Oh dear. It's not good. Okay, I'm going to write it in the title because I can't find it and you don't need to sit here and listen to me flip through pages. So it'll be in the title, the page to practice. Okay, take care, everybody. We're getting close. Hang in there.